In this video, we're going to expand our game plan just a little to include trig functions, as well as logs, natural logs, and the Euler constant. The good news? It's still going to follow the exact same game plan we worked through in the previous video. Our game plan doesn't change, and that's what makes differentiation awesome. Once you get the hang of the game plan, it doesn't matter what they throw at you. No matter how tricky it gets, you'll be able to ace it. So it's super important that you go through the previous video where we broke down the differentiation game plan step by step and make sure you really get it. Otherwise, this video is going to feel like gibberish. All right, let's jump in, and we'll start with trig functions. In this example, they're asking us to differentiate this expression. Now remember, whenever we differentiate, we always follow the same game plan, which is 1, split up, 2, set up 3, differentiate. So that's exactly what we're going to do, step by step. Step 1 of our game plan is to split up. Remember, we split terms at plus and minus signs that are not inside brackets, fractions, roots, or exponents. So in this example, we can see we're going to split at the following signs. Look carefully. We didn't split here because the plus sign is inside a bracket. We know the goal of split up is to take a complex expression and break it into smaller parts, to make it easier for us to differentiate each part individually. And with that, step 1 is complete. Now for the second step of our differentiation game plan, and that is to set up. So we need to set up the structures for how we're going to differentiate. Very important, if you remember correctly, we do not differentiate in this step. We're just building the structures that we'll use to differentiate in the third step of our game plan. Now, to build the structures in our game plan, we always use the following table, where we looked at what the x looks like in each term we split up, and that helped us figure out which structure to use for each one. Right away, you'll notice that in our structure column, there are no trig functions listed. So what now? Very important to remember, we are not differentiating in this step. We're just setting up the structure. And when it comes to any trig function, no matter what it looks like, we treat a trig function in this step just like a normal single x. Important, it doesn't matter whether it's a basic trig function or a trig function with a bracket full of x's. In step 2, setup, you treat any trig function just like an x. When you treat it like an x, it becomes easy to set up the structure. If we look at the first term, we'll see it's 2 x's being multiplied, so we're going to use this structure. In the second term, we see it's just a normal single x, so we'll use this structure. And in the third term, we see the x is up in the air, in the exponent, so we'll need to use this structure. So once we've completed our structure, this is the answer you should have. Pause the video and make sure you've set up your own structures correctly like this, using the table. And with that, step 2, setup is complete. Now, for step 3 of our game plan, and this is where we finally differentiate. If you remember from the previous video where we worked through the game plan step by step, this is where we spoke about the cupcakes. The cupcakes helped us decide whether what we're differentiating is a simple or a composite function. It came down to this. If what we're differentiating is in brackets with a power, it's a composite function. If it's not in brackets with a power, it's a simple function. This was super important because these two types of functions are differentiated in completely different ways. For simple functions, we use the usual shortcut, the circle trick. But for composite functions, we had to use the chain rule. So now, with our example, we need to identify which functions we're dealing with and which ones we need to differentiate. Remember, we only differentiate the parts in our structure that have d dx stuck to them. So we only differentiate these, and the rest, the parts that aren't highlighted, we just carry over as is. So as we now start to differentiate, we can see that the first one is just a normal simple function. So we use the circle trick. And when we do that, we get the following answer. Look carefully. The cosine of x is carried over exactly as it is into the answer. Now, for the rest of the parts, we need to differentiate. We'll see that they're all trig functions. So how on earth do we differentiate trig functions? The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.